All right, here we go with the first lesson of our Intro to Calculus. We're using lesson 6.1 from our textbook just to get things started, and it takes us back to some basic algebra stuff. But you'll see as we progress through the lessons and eventually get into our calculus chapter how it all ties back into these concepts. So here we go, just with the first part of this. So identify gradient, which is just another word for slope, the y-intercept, and then graph it. So in order to do that, always helps to get y by itself and put it into slope-intercept form. So I'm going to start by subtracting 3 and subtracting the 4x over to the other side as my first move. So that becomes a negative 4x and a negative 3. And then you can see with the negative still here, I would then divide everything by negative 1. So it becomes a positive 4x and a positive 3. So you can see that my gradient is 4 and my y-intercept is positive 3. And if we were to graph it, again, just going back to just the basic idea of slope-intercept where we start with the y-intercept at positive 3. So that would be our first point. And then according to our gradient, this is a 4 over 1, so up 4 over 1. Try to keep this small so that it fits. So something like that, and we'll get our line from those 2 points. So moving over to the other one here, so we have just drawn the line, so just making the graph. We have a gradient or a slope of negative 2, and then we're given a point that it passes through, and in this case you can see that that point is the y-intercept, though it could be any point. It doesn't have to be the y-intercept, but in this case it is. So right here at 0, 1 is our starting point. And then from there, we're going to use a slope or a gradient of down 2 over 1. So down 2 over 1 would put us right there. And so here's where we get the line through those 2 points. Nice and simple. On the first one, I guess we could write an m equals 4. That was our slope. And our y-intercept, which we can usually call b, was our positive 3. So if it does say to identify those like it will in the assignment, then want to make sure that we're doing that as well. Going on to the last part of this, so just putting some ideas for linear functions into a table. You can see that we're starting with 7 liters of water, and if we're losing 1.5 liters every minute, that means every minute we're going to subtract 1.5. So as far as the table goes, you can see when time was 0, we were started with that 7 liters. After 1 minute, if we lose 1.5, that would put us all the way down to 5.5 liters. And then every successive minute, we're going to continue to subtract 1.5, down to 2.5, down to 1. And at this point, you could see after 5 minutes, think logically about this problem. If I subtract 1.5 from this, I would be at negative 0.5. But consider logically, if this is talking about a jug of water, I can't have a negative amount in there. So after another minute has gone by, we're now just hitting 0 at this point, right? Because I can't carry into the negatives in terms of water in a jug. So just to finish off the graph on this, again, we're going to keep in mind here that because this is a word problem, now if this was just a regular function with a regular table of values and they were not assigned a meaning like these ones were, then we would just get a straight line that can carry into the negative, but we always want to take into account if it's a word problem what these values stand for, and in this case if it happens to be the amount of liters that we have in this jug, then we have to consider that we're not going to get into the negatives. In this case. So that's just something we would have to keep in mind. So we started up here at 0.7, we went to 1, 5.5, went to 2, 4. You can see I'm just going to keep going, subtracting 1.5 for every minute. And again, this is where it would have carried into the negative, but because I'm going to consider the word problem for this, really as I continue on down that line, somewhere right here where I hit 0, it would no longer go any further. So for this problem, our line would basically then continue on that direction as time goes on, because we're just going to remain at 0 no matter how many more minutes you put into here, we would just be at 0 at that point. So to answer the final question on this lesson here, so would it take 6 full minutes for the jug to be empty? And we can see by the graph and by the table that we did up top that it would happen somewhere before that, somewhere before the end of that 5th minute.